Hello, everyone. Welcome to another session of ExpoLab Blockchain Speaker Series. And today is my great pleasure to have Peter Lee from R3 joining us. He is in charge of the whole blockchain development community of R3 based in New York City. And he's been the blockchain enthusiast for some time right now. And so with that, please take it away. And we're all excited. And thank you for joining us today.
Thank you, Professor Mo. So hello, everyone. So my name is Peter. I work for the company R3. So we are an enterprise level blockchain platform company. And me personally, I work in the developer relations team. I basically help foster and support the open source community of our open source product called Corda. So in today's lecture, or today's talk, make it less informal. So the first half gonna be a little bit introduction about our company R3, and then our vision of how this blockchain industry is going right now. And I'm gonna start talking about our product, our architecture, the network, consensus, node tree, and node. And the second half, starting from 5:20 all the way to the end of the session, gonna be the sort of more technical sessions. I'm gonna talk about the smart contract on our platform, and I mean, if we have time, I'm gonna show you guys the applications in real action, like how to run it, because our product does not need to a lot of learning. You can quickly get your hands on it within a couple hours. So yeah, let's begin. So let me introduce R3. So basically who we are. So the company R3 originally is started as a consortium, or you can think it as a workshop, just like today. So originally 8 banks in New York City, they come together and then sit in a nice meeting room somewhere, from the Empire Building or something. So they come together in the late 2014, and then they sit down and then say, okay, there's a new technology called blockchain, and it started by someone called Satoshi, right? And we don't know who that is, but it looks pretty. Basically, they think it's legit. However, the question they have is, how can they benefit from this new technology? Because you might be surprised that banking industry has a lot of technology involved in their system, even though their ledger keeping system, or you think every time you go to the bank, it's it's such a pain to go through a lot of process. However, they still have the state-of-the-art technology. So late 2014, they come together and then sit in the room. They want to figure out what's blockchain. And then that's the first roundtable. And that's actually is the beginning of the company R3. So R3 was formed from that roundtable on one mission to figure out what's blockchain. And by the end of 2015, basically the whole roundtable, the workshop, starting getting more bank members, and then we finally looking at by the end of 2015 by 42 bank members. And we actually basically submit a report and tell all the members that, okay, what is blockchain? Blockchain is a DLT system, is a distributed ledger technology that basically let what you see, but basically let what I see is what you see. So it's a mutual trust and frictionless business sharing or information sharing system. And after we submit that report, all those bank members say, okay, sounds pretty interesting. It sounds nice. So can you give me one? Can you give me a good candidate, either to use Bitcoin network or the Ethereum network to basically let us benefit from it? The answer is no, because if you guys know, it's the 7th week of your course, all those Bitcoin or Ethereum, those are all public networks. And for the banks, there's no way they're gonna put their information broadcast to every single node on the network. So R3 shift our mission to start in research and development. By the end of 2016, Corda open source general announced. And then that's just free version of the software, but it doesn't meet all those bank requirements or high regulations. So we continue to invest and then developed. So we have Corda Enterprise by the July of 2018, and then the story continues on. Now we are a company with more than, it says 200 plus financial institution by the August of 2018, but now we are looking at almost 300 plus to 400. So that's like the timeline of R3. So basically you can think us originally started as a membership working group, but now since we have our product, now we are a partnership company who offers a product, which is now we call what we call Corda. So we discovered the power of blockchain, which is remove the costly friction in the business transaction by enabling institutions to transact directly using smart contract. And that's basically the results that we told our bank members, and that's actually is the mission, or that's like the foundation that we are stepping on today to offer a frictionless business transacting scheme. So that's basically our mission and our vision of blockchain technology. Next slide is on basically is what we are offering. We are offering Corda and the Corda Enterprise. So this is more like sales pitch, but I'm not going to go too far. So the primary product, the free version is the Corda open source in the middle. But if you're talking about going into the industry, really let your application deploy in the production environment, you got all use the benefit on the outside circle. So that's also like our revenue model, if you guys are interested. This slide is the same. On the left, we are open source. On the right, we have Corda Enterprise. So this goes on like how we can basically run the ecosystem. So we are a platform company. That means we do not develop applications. We only offer software development kits. So those are like the SDKs. So students like you guys or company as those like independent software vendors, those are our partners. So they develop applications. And then when they develop applications, they deploy on the network, and then the ecosystem runs like that. So we are not an application company. We are only doing the platform. So yeah, so that's like a very quick introduction of the company. Any questions? Any people are like want to know like how we make money or stuff like that? Any entrepreneurs here? Okay, cool. So we also have a like QA session at the end. So let me know if you have a question. So yeah, let's talk about Corda. Corda, we think ourselves, like we call ourselves the third generation blockchain platform. Why we call ourselves the third? Because before we have the first generation and the second generation. I mean, like by our standard. So let's talk about the first generation. So first generation, we think the Bitcoin and Ethereum, they belong to in the first generation because they are they do not have strong privacy, meaning they are on a broadcast model. The information is encrypted, of course, but all the block or all the encrypted information is broadcast to the whole network to ensure a consensus or a mutual understanding of the information. So that's the first generation. So the downside is no privacy. Second one is network inefficiency. The Bitcoin, according to its algorithmic rule, is every 10 minutes to generate a block. So all the transactions happen between the 10 minutes get packed in one block. But that's just doesn't work in a real business system or a financial system. The transaction cannot wait 10 minutes for finality. Right now, we're talking about like the future we want for business transaction is real time, real settlement, real conciliation. So that's just won't work. So the second generation is a modified above of the first generation and more focused on the privacy. So we're talking about Hyperledger Fabric or other like other chains in the Hyperledger ecosystem, and also the Quorum, which is a private version of Ethereum developed by the JP Morgan. However, they also have their issues. Their issue is back then when they were developed, they are very strong in develop a network in one industry or one ecosystem. That means they are creating silos. So they are not that good with interoperability, meaning like, for example, if you are in a medical records sort of network, your information is transacted all about insurance or your medical record, your patient information. However, if you want to get any information or any data allocated out of that network, is a little bit difficult because, or let's say it's quite difficult because the network is set to do one thing. So in our vision, in our mind, all those networks should be connected. For example, the medical record or the patient record system or network needed and should have connected with the insurance network, meaning all those information should be flow seamlessly, and there should not be any caveat setting up those networks. So that's how, like, that's our focus, and then basically the purpose we have in mind when we develop Corda, what we call third generation. It's a private but interoperable business network with transferable asset. And and also we are able to do deliver versus payment. So that means like you take the asset and then you can have a ledger or asset to settle it in real time. So little quick summary is third generation blockchain Corda is the blockchain for business, because we focus on privacy. It's a private chain, and it has scalability because well, I can talk about in the next slide. And lastly, interoperability, because we do not want to create silos within the industry. We're looking to build a whole ecosystem that everybody can talk to each other across a different business network. Second one, applicable to all industries. So it's also one of our strengths is we design Corda aiming to comply to the highest regulated industry, which is the banking industry, and we did it. So that means all from compliance level and from the application or like the applicable levels, Corda is able to apply to any industry from the regulations or from the implementations. Lastly, is what I have been saying over and over again, is our vision is to create a cross-industry ecosystem. So yeah, so let's actually talk about what we are really good at. So the first one is strong identity. So with Corda, it's a private permissioned blockchain, or you can say a private permissioned distributed ledger technology system. So private meaning we have a doorman in our in the network. So like when you implement it in the code, it's called a network identity manager. That means when you want to onboard a client into your network, all those information of the client can be audited. And when they are onboarded into the network, all the other network participants know exactly who he or she is as a participant of the network. So that's the first thing, because all the customers that we are dealing with, all the clients we are dealing with, and even let's say like real life, how business goes is you will never do business with someone you don't trust. We're talking about $1 million deals. We are not talking about Craigslist deals. So you never buy something from the people you don't know. So with Corda system, strong identity is what we guarantee to our clients, the first thing. Second thing is privacy. So of course, everything is encrypted, but also in the Corda system, the messaging scheme or the transaction scheme is peer-to-peer. Is from, or you can call it point to point. It's only getting the information shared around relevant counterparties. So there's no broadcast. Your information never leaves you and your counterparty's database. Nobody gonna see it. Well, I mean, unless you want them to see, you can like purposely send to them. So that's the second thing we guarantee. The next thing that is sort of outstanding is how we have basically two layers of consensus mechanism. The first one is you can think it off-ledger consensus. And that's actually tied back to the first one, the strong identity. So thinking about private chain, that means everybody knows who's on the network. I mean, if they want to find out, if they never care, they just never try to like look up the network map. But if they want to know who's on the network, they can look it. So that means the consensus, the business consensus or business logic consensus is like 50% reached there because you know who you're dealing with. And if you just don't want to do business with him, you just don't. So that's like how, people do business today anyway. So, right, like, you know who you're dealing with and you trust your counterparty. So that's the off ledger consensus we're talking about. That's the first more intuitive layer of trust that we're talking about. The second layer is the blockchain stuff, which is the on-ledger consensus. We have a system of notarizations, and in the notary pool, you can deploy your consensus algorithm. For example, you can deploy a BFT, you can deploy like a raft, you can deploy like a simple version of like a round robin, like that. That's just like the simple list. Simple is the consensus protocol is round robin. It's like you just every time you use the next notarization worker, and then it's all going around the circle. So that's our on-ledger consensus layer. So with both layer, we guaranteed consensus. I can talk about a little bit more about consensus in the later slide. Next one is performance and scalability. So for this one, we have a report. So, if I start talking about performance, then you will think it's like I work for the company. But in 2018, the New York, one of the New York clearinghouse. So if you are in the financial industry, you will know a clearinghouse is a key institution in the like trade finance system. So a report done by a clearinghouse called DTCC did a report of using multiple blockchain platforms, including Ethereum, Fabric, Corda, and back then there was another platform called Demo, and they put them all four platforms into a stress test. And Corda is the only one that can pass the test of a NASDAQ stock market end of day closing scenario. So the report, I can send you guys the full report. I can just like send a link to Professor Mo after the lecture. So that's basically a third party auditor saying that we are definitely have a strong performance and scalability. And with Corda 4 right now out there in the field, I think with the correct configuration and the enterprise level of the software, we can do at least 40,000 transactions per second for the network, 40,000 transactions per network. So that's that. Next one is global interoperability. So for this one, there are also two layers. So let's talk about interoperability in a way that your blockchain software, your blockchain application need to interoperate with your existing system. So Corda, the source code of the project Corda is Colin, which is basically a little bit more simpler version of Java, or you can call it advanced, lazy version of it. So, but you can definitely write your Corda application in Java. So basically, we are a Java support language, and on the system that is running Corda system. Your Corda node is running in a Java virtual environment, a JVM. So that means we are basically interoperable with any legacy system at today. So a lot of banks use Java in their backend system. A lot of like insurance company, medical record company, hospitals. So anywhere with Java, you can deploy a Corda application and then make it interoperable with the legacy system. If you think about Fabric, if you think about Ethereum, the developed language is either Solidity or Go. Well, Fabric also has Java too, but that's only I think they develop as a second language, not their primary language though. But anyway, so that means if you use other platform, you might run into an issue of does your blockchain applications is able to talk to your backend system. So with us, now it's an advantage because we don't need to worry about it. With Corda applications, it's just seamlessly interoperate with your legacy system. So that's the first layer of the global interoperability. The second layer of global interoperability is the things I talked about in the previous couple of slides is what we are looking to build is not just one streamline of application in one industry. What we are looking to build is in is the ecosystem. And with the next slide, yeah, let me just actually go to the next slide. With the next slide, you can actually see that Corda has multiple industries. On the left, we have the capital market, trade finance, healthcare, bottom education, bottom right, government, insurance, commodity, top right, finance. We are very strong in finance. You can you can find some interesting logo there, like Thomson Reuters, Wells Fargo, MasterCard, etc. So that's the second layer of global interoperability is any application that you develop will sit on a node. On that specific node can also at the same time has other applications where you can now have your application talk to each other. So that's why that's how we reach like a true global interoperability is your application is not only serving one purpose, your application can actually talk to other application or like through your node. So that's a second layer of interoperability. So let me go back a little bit to my last slide just to finish off there. So lastly is open source. Back then, like 3-4 years ago, open source might be a thing to brag about, but now it's almost an industry standard, so nothing too much there. But the network is, the Corda platform has a global network called the Corda Network, the TCN. It's run by the Corda Foundation, not by us, right? We are the company of R3. So we are a platform company. We are a tech company, but the Corda network is run by basically a foundation, or you can think it is as a committee. So R3 only has 2 members in that committee, and so we don't make a say on what to be able to change on the network. So we can make a suggestion, we can make a proposal, but excuse me. But if we want to make a change to the network, then it has to get approved. So the Corda network also is another thing that benefits the Corda ecosystem is that's basically give you the place to deploy your application on. So that's the last thing. Also gonna quickly ask a question like, is there any questions? Am I going too fast?
No, I think everything is good. So I think what would also be interesting is to, I mean, you mentioned you're going to talk about the consensus protocol itself, and perhaps this cross blockchain or this interoperability that you refer to is that would like be similar to a cross-chain transaction or atomic swap, and so maybe at the protocol level, how do you connect, for example, a Hyperledger and R3, for example? Some of the assets sits in Hyperledger, some assets sits in R3, and then how does it at a protocol level, how does that being achieved, for example?
Cool. I don't specifically have a slide for that, but I can answer your question. So we did have a cross-chain transaction or like a pilot project done before. It's actually quite famous. Is Project Jasper. It's a CBDC project. It's the central bank digital currency project that started developing by the Bank of Canada a couple of years ago. So their goal is to have the assets on like basically have the system managed by the Corda system, but have the bank finally settled the transaction or settle the payment via quorum. Like they are just also like trying it out. So the quorum is a private version of Ethereum developed by JP Morgan. They wanted to make it the bank blockchain, but I think a couple of months ago they have an announcement. Basically, they dropped the project. But the thing is, a year ago or so, we were actually by client demand that want to interoperate Corda with Quorum, and we did it. So how we achieve it, you can think it as when an asset is issued on both ledger, basically a method or a function is triggered on both network, and an asset is basically imaged on both network, and they can start doing whatever they want. And when you want to consume the asset, and they basically get spent because Corda uses the UTXO model, the unspent transaction model. Unspent transaction output model. So basically, if you want to take any asset or any data out of the blockchain, you need to spend it. So with that mechanism, so if you want to move an asset from Corda to the other one, you basically you mirror it, you image it, and then on the Corda network, on the Corda ledger, you spend it. And then that asset basically moves to the other ledger. So that's how we can basically trick it. But if you think about the atomic level of asset cross-chain, I think we do not actively research into that aspect. We only fulfill customer demand case by case. But yeah, because like if you think about different assets on different chain is basically it's a different type of representation. So in Corda, actually in the second half of the talk, I gonna explain how is data or how is asset represented in the Corda network. So I'm not too familiar with other blockchain platform, so how they are represented, but definitely it's different. So right now, if you want to know, is there an atomic way? I think maybe not, and people are still researching into that. So yeah.
And in terms of, so from what it sounds like from earlier on, just looking at a consensus within the R3 network, so you kind of get pluggable choice. You can like put the Raft in there or Kafka in there or PBFT in there. What are the different choices that one kind of has?
So let me actually jump right here. I'm gonna skip a couple slides. So that's it's about like the use case, but we can talk about it at the end. So thinking about the Corda architecture. So Corda is again a permission network, provides peer-to-peer communication on a need-to-know basis. So all of the consensus is pluggable in the node tree. So the node tree provides basically three functionalities. The first one is double spend. You see on the screen, like the buyer one asset split into seller one, seller A, and seller B. So this is double spend. And second one is a timestamp. That's just some simple functionality. The last one is validation. So how is the consensus protocol deployed into the node tree is if you just want to go through the maximum performance, the maximum transaction per second, you do not use any consensus mechanism because we are a private permission network. Everybody already know who they are and they already have the off-ledger trust from the beginning. So they use this network just to share information on a more private way. So in that case, there's no consensus deployed to the node tree. However, if we are talking about a little bit less trusted environment that the participants start, not feeling comfortable using, just let the node tree only check for only check for unique consensus. They can start basically saying that, okay, I want dedicate a service worker into the node tree and make the node tree a node tree pool. So that means, so in this example, you see in the network, we have 3 participants, the Colorado River Authority, Titan Technology Partners, and Base Trans Group, right? So one is regulator, the other one is just like some companies. So those companies, they don't trust each other, and they start thinking the node tree is compromised, right? They want to have their node tree service worker to be part of the notarization process, so they can dedicate it one node tree worker in, and then make it a node tree pool. So instead of having one node as a node tree, you can start having like a, let me actually draw on this. So let me see. So pen color red. Okay, so instead of a node tree, you can start having a node tree pool, and it become a group of different node tree workers. And one of them is from the Titan Technology Partners, and the other one is from Base Trans Group. I mean, right now we only have 2, so it doesn't very apply to any consensus mechanism. But if we're thinking a large network have like, let's say 10, 20 participants, and they don't trust each other, and then they don't trust the node tree. So we're gonna start seeing more and more node tree workers in the node tree pool. And that's where you deploy your BFT, your Raft, your PBFT consensus. So transaction, for example, now we are talking about a transaction between Titan Technology Partners and the Base Trans Group. That transaction is gonna send to the node tree pool to do double spend. This is a double spend validation, or like a double spend check, right? So that's the primary functions of the node tree. So that's what we are doing here. So this transaction is going to the node tree pool, but how is the node tree going to speed out a result? It's through those consensus. So, well, as I mentioned, like if it's a total issue free, like no problems, everybody trusts each other, the node tree just one single service worker, and then it's check for double spend, and then it speed out the result. Okay, if there's double spend. But in a little bit more chaotic situation, there are multiple node trees workers, and then we can start having BFT, PBFT, and then you just deploy them into this smaller network of node trees, and then when a transaction come in, they all start doing stuff, and then they're gonna altogether speed out the result, and then that result will be the validity check of the transaction. Does that help?
Yeah. So yeah, no, that's excellent. So basically, you have these different nodes that kind of join together to form the R3 network. They all have potentially a copy of a ledger, but the one who's certifying the transaction or endorsing a transaction, it goes to this notary service, and this notary service could be a single node, or in some deployment, it could be many nodes. And if there's many nodes, then they're probably running a consensus. You could be a crash tolerance like a Raft, or you could have.
Exactly.
I see. Okay.
So that's also like what I talk about is we have 2 layers of consensus. So one is like in the perfect scenario, everybody trusts each other. The off ledger consensus already make everybody satisfied. So they aim for the maximum TPS because the transactions just come into the node tree and come out. That's it. But if we're talking about more futuristic scenario that distrusted parties start doing business with each other, they can chip in their node tree service worker to have a node tree pool, and then they can deploy whatever consensus protocol into the notary pool, and then basically trust that result instead of the off-ledger consensus. Save them some time, but the TPS actually gonna become lower because this work actually requires time, of course.
So excellent. So two questions. So in terms of this network, so once a transaction gets certified by the notary service, then when is it that the transaction becomes committed? I mean, it's certified, but when is it actually now becomes executed and committed? Is it the case that all these three other nodes needs to agree on the commitment of it, or as long as one of them does, how does that part work?
So good question, but it's actually jumping around. But I can quickly answer your question, and then let's go back to the flow.
No.
So,
I don't want to disrupt your flow. So if you're going to be talking about that later, let's go with the flow that you have. I don't want to.
Okay.
So let me ask you one more question, I guess, on that figure.
Sure.
So now, in terms of sort of kind of understanding sort of the characteristic, is that either in a regular deployment or in extreme deployments, how many nodes can they sort of join as these, like Colorado River? So how many nodes can it scale to? Are we talking about 20, 50, 100, 1,000? What is the kind of the scale?
So if you talk about the network is unlimited. So there's no upper boundary, but you got to consider about the performance, because if you're going to have more node into the network, you're going to start having more notary, because otherwise all the transaction going to coming into the notary going to become exhausted. So right now we have basically a test version of our network called testnet. But so that's what we use for like internal testing. We have 5,000 Corda node on the testnet, and we have roughly 5 notary on the testnet network. So that's running completely hassle-free. On the publicly available global Corda network, we have a couple less than 1,000, a couple hundred live node who's actually actively doing production or pre-production transaction. And for that one, globally, we have 5 publicly available notaries for them to use. So if you think about upper boundary, no, there's no upper boundary, but you gotta find the equilibrium between a notary and the parties, because if you want to bring in onboarding more parties or node into network, you gotta start thinking about the TPS of your notary.
And what is the sort of the transaction throughput you get for those deployments? What is the TPS?
I mean, that's just case by case. We don't know. It depends on how.
Let me just take one example. Just I guess one. Roughly speaking, I'm talking about 10,000 transactions per second for one of those cases you mentioned. 500 transactions per second. What is the one deployment? I mean, any deployment that you want to kind of share the data.
Okay. So if you're talking about deployment, is one business deployment, like one business logic deployment, or the whole network? Because on the whole network, we have a multiple business deployment.
Is that like being sharded?
Yeah, it's shared because there's only one network.
No, not sharded. Is it sharded? Is that you have the same infrastructure and you deploy multiple network, but these transactions doesn't have to be replicated in the entire network. Is only
no. It's all the transaction is only within their own network, but the notary is shared, and their parent node who's actually doing those transactions is also shared. So if you want a number, I gonna give you the performance number is roughly 20,000 transactions per second for the enterprise level network. For the open source, you will not get that number, but for enterprise, yes.
And that's the bottleneck by the notary service?
No. So the notary service is actually a different mechanism of the node. So the notary doesn't understand what's a smart contract. It doesn't understand like what's going on. It's completely doing different things. So the notary has a different performance measurement. But for that one, actually, I don't have the number. We only the publicly available information we only have for the node, not the node tree. But the node tree is maybe 10 times or 20 times faster because it doesn't do anything. It just sees the transaction hashes and then record it and then check it with a hash that it has seen before to prevent double spend. So that's all the node tree do.
I see. All right, thank you.
All right. So next slide. So I think you already actually said it for me. So each node of the ledger actually sees a ledger differently. So in a simple network of Alice, Bob, Carl, Ed, and Demi, so they can freely do transaction with each other peer-to-peer. So in that scenario, information like the number 1 and 7 is only shared between Alice and Bob. That means Carl, Ed, or Demi, they will never see what's going on in transaction number 1, transaction number 7. And looks like Carl is a popular guy, so it has a transaction 2, 3, 4, 5, 6, and 9. So he's friends with everybody. So on his node, in his database, he's storing the transaction or the information for all those transactions. So that's basically the ledger system for the Corda platform. That provides, again, the privacy.
So let me just ask you that. So that was a very nice figure. Let me just ask you one more question here. So in terms of the redundancy of the data getting propagated in the network, is it then proportional to the, I guess, the relevance of the transaction? So the transaction 1, since it's only related to Alice and Bob, it's only going to be stored in the Alice and Bob ledger, or?
Yeah, it's only gonna store at the Alice and Bob's ledger, and I think you said redundant. It's actually not redundant because when Alice and Bob is actually doing the transaction, both Alice and Bob is basically need to see that data. So it's not like a redundancy, but it's just like it's a need to have.
Well, no, redundancy in terms of that information gets redundantly stored 2 places as a good.
Oh yeah. That's also is sort of
replicated. Like, that information is stored in 2 different places. So if Alice loses its ledger, there is Bob, but it's
also for the data recovery purpose.
Yes, that's what I meant. Yeah. So in terms of, so now if you want to have a higher degree of replication and redundancy, then what do you do? If I want to kind of make sure always I have at least 10 copies of the data, then what's the means to achieve it? I will just have multiple versions of Alice and Bob. Is that the way to do it?
You talking about like data disaster recovery, like for example, Alice when the Alice node when crashed?
Sure. Yeah.
So we do have a mechanism that you can recover your transaction from your counterparty. So if Alice node when completely crashed, Alice can start a new node, rejoin the network, and identify herself, and then reach out to Bob saying that, hi, I'm Alice. I'm the legit Alice, so I can start a function, and then to retrieve all those transactions that she did with Bob. So.
And how about the transaction that Alice just did it with herself?
Okay, so two outcomes. The first outcome is if she just do a transaction with herself and never use that transaction to do any further transactions. And so that's the first scenario. In that scenario, she's done. She gonna lose that transaction because she did the transaction and she's not using that. She's not like utilizing that transaction anywhere else in the network. So that means she's only having the copy to herself. So that transaction, that copy of the data is gone. However, she can mimic the exact same transaction to create a exact same copy of it. It may sound a little bit strange, but Corda use deterministic Java. That means even you use generate a hash, like regenerate a hash. If you use all the same input, the hash is the same. So that's something that we sort of develop and inject into the Corda system. Is if your transaction is gone, you can basically create a new transaction And that new transaction is exactly the same that you created 10 minutes ago. So given the fact. So the second scenario is Alice do a self-issue, right? To issue herself like some like $10, and then she's using that $10 with Carl. So and then her node went down. She started a node. She can go to Carl saying that, okay, since I did the second part of the transaction with you, you should have a copy of basically everything, from also including my first part of self-issuance. So I mean, it doesn't sound that secure, but that's the level of transparency that we are having in this DLT system. Is if I'm giving Carl some asset, Carl needs to know where I'm getting that asset, because that's just what we are promising in this DLT system. So in that case, Alice can ask Carl to send back her copy of self-issuance.
All right, cool. Sounds good. Thank you.
So the next one is about the Corda network. So that actually covers quite a little bit stuff that we already talked about. So I'm just gonna quickly go over that. So on the outer ring, we have the identity manager, what we call the doorman. That's do the off-ledger auditing. That's make sure everybody has their clear identity, their strong identity of the network. And in the middle, you see a cluster of like random dots. So those are just like small business network that connect to each other, that are able to talk to each other. And in between, you see some yellow dot. Those are notaries or can be notary pools. And the green dot are those Corda nodes by other organizations. So that's just a simple snapshot of a Corda network. By the way, like you can completely start a private Corda network by yourself. For example, Professor Mo, if you want to start a Corda network with all your students in the class, everybody have a node on their home laptop, you can also do that. And then you will become the identity manager, create a whole network, etc. So it's not just like you have to use a public network. You can also have a private network. We also offer that. So enough talking about the network. Let's talk about the Corda node. So what exactly can the node can do? So the Corda node, in a simple way, it abstracts away the complexity of updating the ledger. So you can treat it as a engine that help you do all those things: messaging, concurrency, storage, disaster recovery. We also talk a little bit about that, peer discovery, key management. So if you think about a true blockchain system, what you have is basically a public key and private key, and then some encryption going on. So it's very difficult that you try to deploy some business, try to remember other people's 256 bit of public key, and then also remember your private key for every transaction. So the Corda node help you do all of that. You don't need to worry about it. So how it does it is it takes the instruction from you. You write your smart contract. It can be a token issue flow, create a mortgage flow, or crowdfunding flow. It's an instruction. The instruction is sent to the Corda node, and the Corda node give you a signed transaction. The signed transaction, including both your signatures and your counterparty signatures. If you have any regulator signatures, they also like go there and collect them, all done for you, and then give you this signed transaction. And the signed transaction now also in part of like the process going to send to the notary for notarization is going to coming back. And the last stop is the finality, meaning ledger update. So the Corda nodes take the signed transaction and then just record it or attach to the previous block of your data stream. So that's what the Corda node does. Yeah, so that's it for the Corda architecture and Corda basically platform introduction. I'm gonna stop right here. Any questions? So the next part, I'm gonna talk about smart contract. Cool. All right. Sounds we're all good. It's also 8:30. Okay, so we have like 30 minutes. So let's talk about the CorDapp. So CorDapp stands for Corda Decentralized Applications. So people also refer to the smart contract. And CorDapps are just like binary jars that are stored inside of the Corda node. So in the previous slide, we talked about the Corda nodes are the abstract engine that help you basically do everything, right? So the CorDapp or the Corda decentralized application is the instruction, right? Basically, all the functions you write, all the contract rules that is required in the business logic are all in this CorDapp jar. And also, to fulfill our vision of creating an interoperable ecosystem, you can have multiple jars. You can have, meaning multiple CorDapps in your Corda node. So in this very simple chart at the bottom, you see we have node A, node B, node C, and if you think it as a Corda network, you also need a node tree, but I just don't have it in the chart. But you see A, B, and C, they both have Hello World CorDapp jar. So that means they can do all the functionalities and follow the contract rules for Hello World CorDapps. So that's like one application. However, node B and node C, they decide also deploy a whistleblowing CorDapps in their node, so they can maybe like tell something behind node A's back. So that's also doable. That's actually a good scenario. Is like you can maybe opt into a whistleblowing program of a blockchain system. So you can help monitoring whatever the network business system or something. So yeah, so that's basically the relationship between the CorDapps and the Corda node. So let's now talk about how the blocks chains up in a CorDapp, and also like how is data represented in the Corda system. So data are stored as states, like literally state. You're gonna see in the code, it's called state in Corda nodes database. And states are updated via transactions. So in this chart, you can see it as the state use transactions to chain up. And the backtrace is easy because you just need to find the latest state. And from the state information, you're gonna see, okay, it's gonna tell you which transaction that generated the state. And then you just use the transaction hash to find the previous state, which is already consumed state, and continue to origin to get to the genesis state, meaning like the first state. Corda adopts a UTXO model and spend transaction output model, so data is never deleted from the database. Hence, Corda holds the immutable nature of the DLT system. In the bottom chart, is explain like what's the UTXO model. Also, like the Bitcoin model, it's like you never delete stuff. You only use what is computed into the next block. So, for example, the first transaction, you have input and output, input 0, output 1. And you use the output 0 into the second transaction as an input. And then like you compute like some output. It doesn't really matter. And also for the output 1 that is generated from transaction 1, you use them in the third transaction as the input, and then you can have like some other output. So that's how the data is connected and how like the block chains up in Corda. Okay, so any question there? Cool. Components of a CorDapp, smart contract and Corda. So we talk about state, which is the representation of data, like the data representation in the Corda platform. It can get consumed, updated, and eventually stored, meaning like stored to the ledger or like chains up. The second important component of the Corda smart contract is the contract. So it's like playing a word game because we use the word contract again in the smart contract. But this contract is actually the more intuitive contract. It's the actual rules of your business logic. For example, if I said, I want to borrow a book from Professor Mo, and one of the rules is Professor Mo applied to me is you have to return the book within a week. So the contract is actually gonna just state that the asset, which is the book, need to be returned from the date of the borrow, or like the day that professor lent it to me. And that rule is gonna get strictly enforced when I return the book in a different flow. So if I do not follow the rules, or like, for example, I pass the time window, the contract actually gonna red flag the note saying that I declined this transaction. So my proposal to the ledger writing, meaning that, okay, I return the book, I want to, update it on the ledger, will get a reject. So that's the second component. The third component is the flow. So that's actually, Professor, one of your question earlier is, after the notarization, how is the transaction committed to the ledger? So there's a chart I'm going to talk about in the later slide, in the bigger slide. So that's a flow. Those are the three components. So the first component is very easy. So let me actually get into more detail of the Corda contract. So the ledger update is done through transaction. We've seen that in the previous slide, and the contract verifies the validity of transaction. So if you want, if you thinking about a Corda transaction, what does it mean? The Corda transaction just meaning an input and an output, and like a comment that's explain the intent of the transaction, but I'm not having it here. It's not that important. So you have the input, which is an existing state. You do some calculations. You're going to have an output, which is a desired output state. You encapsulate them into a transaction, which looks like that, and that transaction need to go through certain rules. When it's all passed, meaning that, okay, so in the book borrowing scenario, I return my book in good condition. That means I didn't draw on the book, or I didn't tear off the first page or something. Everything looks fine, and I also return it within the time window. Ledger updated, the return of the book action is recorded. However, if I do not return it with satisfy one of the rules, the Corda node gonna, according to the contract, reject my ledger updated transaction. So that means the contract will now declare I will not let that transaction come into the ledger. So it's a rejection. So that's basically how Corda contract works in the applications. Lastly, now we're finally looking at the bigger image, is how does the Corda flow works. So the Corda flow executes the business logic. So flow normally consists of two classes. One is one initiator that's does the proposal, and one responder that responded to the proposal. So the business flow goes, node A, the initiator proposed the update. Himself check the update using the contract, right? Like 1, 2, 3, the contract. And then he signs the contract. So basically this is a self-signing. And then he passes half-signed transaction to the counterparty. And the counterparty check everything, also check the contract. And then the counterparty signs a transaction saying like, okay, everything looks good, right? Based on our knowledge, because there's a certain crucial part, the notarization part, that they don't have the information. So the second party said, okay, everything looks fine so far. I'm gonna send this transaction back to the initiator. The initiator, after collecting the signature from the counterparty, now sends a transaction to the notary, check for double spend. So here's notary gonna do. The notary gonna look for all the consumed transaction before, meaning like all the transaction coming prior to this transaction. Looking for all the input of the previous transaction, because like they sort the input transaction. So all the transaction input hash is stored at the notary. And this new transaction coming in, right? This new TX coming in. This new TX coming in with the input hash and the output hash, right? And then it looks for the input hash, and then look for this bigger list of input hash. So it's make sure that the new transaction's input is not spent before. So that's how the notary prevent double spend. And if notary says, okay, it's a new input coming in, right? I never seen this before. Okay, now I'm gonna add this to my list. So to prevent more people, other people to do a double spend, right? So let's call it 2, right? This is like 2. So the notary gonna record this new input hash and then tell notary, the initiator say, okay, you're good to go. I never seen this input. There's no double spend. You can record and update your ledger. So and then initiator gonna send a message to the relevant counterparty saying, okay, now also you can update your ledger. This is finalized. We are good to go. So this is what happened at the last. So technically, these things should happen simultaneously. But we do see just a network lag, just a couple of nanoseconds, because initiator doesn't need to let the counterparty know. So we make it like a step, but it's not like node A has to finish and then node B does it. No, but it's like they just do it's just a network latency issue.
So just kind of quick question here. So who, I mean, in terms of, I guess, take an example, double spending, who really checks for the double spending? Is it just node A and B who need to ensure that?
Oh, the double spending is checked by the notary, which is the public service worker. So you can think it like that. Nobody is owning the notary. The notary is started when the network is started. So everybody in the network come together, they sit down and then work this notary pool out. So
that doesn't mean that the notary has access to all the data in order to?
No, the notary only store the hash. The notary doesn't care what's coming in, and the notary doesn't know what's coming in. It only knows a piece of data, and its hashes is stored in the notary. The information is not stored in the.
So how does it then determine if there's a double spending?
Oh, so the notary sees a new transaction coming in, and going back to this chart. So the transaction has an input and output.
Yes.
And the notary will look the hashes of the input and then store it in this little is ledger. And so for this transaction, you see the input, let's say is X004. And this transaction get executed, updated the ledger.
So this is a UTX model. So you're assuming the input can only be used once.
Yes,
so if
exactly.
Already used once, then okay.
Yeah, so if in a scenario of like a asset, like fungible asset, so if let's say I have $100 and I go to a transaction, I only like spend 50 of them. So in this, my input is $100 and my output is like 250. One goes back to myself and then one goes to the counterparty. So that's like guarantees the UTXO model will consume the $100 and then now I only have like the $50.
With the new hash, so that goes.
The new hash, yeah.
Okay. And so again, well, I guess that's a transaction. But if you want to do more expressive kind of transaction, like smart contracts, it doesn't really rely on this fact that a write once model. So then, would that be possible, or that's not in the scope?
Can you explain more on the more expressive?
Like a standard transaction. So a standard transaction model in a database is that I have $100 and I only have one account. I spend $50 of it, and I still have my account, and I have $50 remaining in my account. I don't have to create a new account to put my balance. I can just.
I mean, there's no account creation. It's just like your $100, the actual data is being marked as consumed. You're getting a replacement of your original data. So it's like it's continuously replacing the same data with a basically new hash. Everything else is the same. It's just the notary need to have a way to keep track of what is spent and what is not spent. So who
provide those hashes? Who provide those hashes?
Pardon me?
Who provides the hash?
Who provides the hash is when you create a state. So technically, to answer your question, the node the node will generate hashes.
Okay. And also assuming that the node is not malicious.
It's your node, so.
Sure. I mean, so for example, I spent $100, but I still keep $100 in my account.
You can. So that's when the contract rules gonna come in, because the contract, your transaction gonna say, so okay, let's do the math here. So your transaction gonna say, okay, I have $100, and that's your input. Your output is I gonna keep the $100, but I give my friends, like let's say Peter, $50. So technically, you what's gonna happen is you try to keep your $100, right? Can you do that? Yes, you can, because you just read a bad contract. Because a good contract need to identify that your output adds up to your input. So that's
Sure,
like
no, but that's fine. Is that I write a good contract, but I'm the one is anybody else is storing my balance, or is I'm the only one who's storing my balance?
If you do a transaction with others, and you begin with 100, other people will know that you're gonna have 50 left, because he's the relevant party of your transactions.
So put it this way. So now I spent $100. I have $100.
Yeah.
And then I gave $50. I give $100. Let's say $50. I give $50 to Bob, and I do this. I write a well-formed contract, and then Bob gets $50. I get all good. And the notary system, as far as the notary system knows, is that I had an initial hash, and now I have a new hash. And I give what the new hash is. And if I am acting non-maliciously, I put $50 in that new hash. But now I come to you and I say, you know what, I'm going to give $80 to Peter. And I say from that new hash, I give you $80. Bob is not involved in this transaction. The notary service looks at it and says, okay, this is a new hash. It hasn't been used before. And I claim that there's $80 money in that account. And the contract looks good. I give $80 to Peter and maybe some reminder in there.
But the issue is, where is the $80 coming from? You need to have an input into your transaction. Okay, so how do I erase everything? Okay, maybe I go to this slide. So you need to have an input of your transaction. Like you claim that you have $80 for this, like a new transaction.
So I need to. So after that transaction that I did with Bob, I had $50.
Yeah. So that's your new existing state. Like you cannot just create.
So the notary has a proof. Who generates a proof for that?
Okay. So what do you mean? Who generate the proof? So let's say that you want to give a new $80 to Peter into a new transaction, but since you don't have that in your existing state. So
but, I can change my state. How does anybody know that I tampered with my state?
You can change.
Again, I'm not being. So the question, if the note is malicious, and if it can change the state, so how does it? What proof do I need to show if I change the state? I should have only $50, but I
wait. Okay, you can't change the state, because if you change the state, the action of changing the state will be on the record. Like you cannot just go into the database, make 50 becomes 80. So if you do that,
and then why is that? So I guess that's the question. How does that get prevented?
Okay, so your node reads in the database. So you have your $50 coming out of the previous transaction. So the hash of that state is like in the database form is a blob, is a hash. right? But if you go into your database, go to your SQL database, change the 50 to 80, it's a different hash. The object in the database actually changes, like after you encrypt it, like it's gonna be a small little bit change. 50 become 80, and your Corda nodes doesn't recognize it anymore because it says someone, I'm not saying it's you or some employee of your company, is actually messing with your data. And as a node, I don't recognize that piece of data anymore.
Okay, so basically what the notary does, the notary doesn't keep track of the data, but it keeps track hashes of all the data. So
Yeah.
and if I were to, and the notary essentially, so notary is the ground truth. It knows the hashes every account, and after every transaction, the notary will recompute the new hash, and if I don't abide by that, well, the notary find out, well, this hash doesn't match, and that's where it just flies.
So the notary primarily cares about the hash of the transaction is valid or not. So the level of malicious attack that you're talking about is controlled by the node. So the node's gonna look into the database is like, wait a minute, that's not the state that I previously received. You definitely messed something up, which is like the 50 becomes 80. So that's a different state. That's not your old state. And I don't have a ledger of you changing from 50 to 80. So
No, but the point is the entire node is malicious. The node is not going to raise a flag.
Well, that's not controlled by you. That's controlled by Corda. So the Corda node, like then you got to go to the source code to make the node.
So again, I'm talking about being malicious. So that node, something is malicious. So at any layer. So then the assumption is that that node cannot act maliciously. Could be software.
I need to think about, but now I see your point. Like the entire node is corrupted, and it's not calling out the 50 becomes 80. Like it's not calling it out.
And it could be just a bug. Just maybe it's not even it's not a malicious intent. But the thing is, if that node is the only one who has that data, and that the only one who needs to, you have to trust that node. And if something goes wrong in there for whatever reason, then nobody else can say anything about it.
Yeah, I might need to look into that because if it's just another transaction with Bob, then Bob gonna figure it out because Bob has a record. But if it's a different person, let's say Peter, then Peter doesn't know any transaction that it does. So I need to look into it.
Okay, sounds good.
Cool. But actually, that's all I prepare for today's talk. I mean, that's why I say, like, I mean, if I have more time, I can talk about code. But actually, the time is up. Do you want to call it today, Professor?
It's a very exciting talk. So let's just maybe, I think maybe there are more questions from our audience. I mean, thank you so much. It's been very insightful.
Sure. So then I guess let me finish off with, I mean, feel free to drop the question in the chat. You know, I'm watching, like, or if you raise a hand. So I gotta finish up with some like reference. So you can join our community by go to the slack.corda.net. Like basically it's a self-invite website. It's like you go on, you enter your email, and then it's gonna send the invitation link. Our documentation is docs.corda.net. Training site is training.corda.net. GitHub repository is github.com/Corda. The team email contact is devrel@r3.com, and I can also gonna drop my personal email here. So if anyone wanna reach out, I'm also bilingual. I speak Chinese, Mandarin. If you want to add me, we also have like a WeChat group for Chinese Corda community fans. Yeah, so that's all for today. Thank you, Professor Mo, for having me. Look forward to continue to work with you.
Thank you so much. It was a wonderful, and we really appreciate. And on behalf of ExpoLab and UC Davis, we thank you for this wonderful lecture.